So we're going to finish the week here looking at our applications in terms of angles of elevation and depression, where we're talking about things in relation to some horizontal axis, some horizon, where we have an angle of elevation, essentially if we're looking up from that horizon, and then an angle of depression for when we're looking below the horizon. That is not necessarily an angle of sadness, but an angle that is looking down. So, for our examples, the first one we're going to look at is looking up at an angle of 57.2 degrees and a distance of 125 feet to the top of the tower, where we want to estimate the height of this tower. Now, I'll say that this is a bit of a, finagled example, because I think it'd be more reasonable that you would know maybe how tall the tower is and want to know how far away you are, or know how far away you are and how tall the tower is, but need to know the angle that you're looking up at. In any case, we've got this potentially unreasonable information, but because looking at this picture, we can form a right triangle in terms of your position and the height with that angle, where the side opposite is the height that we're looking for. We would have that tangent of 57.2 degrees is equal to A over 125, or equivalently, A is equal to tangent of 57.2 degrees times 125, which, if you use a calculator to get this value, is approximately 194 feet, because I guess that is technically 125 feet that I should be more specific about. That's how you do something with an angle of elevation. On the other hand, suppose a 21 meter tall building casts a shadow of 25 meters. Find the angle of elevation of the sun to the ground. Here we're still looking at an angle of elevation, but now we have the height and the length, and we want to find the angle. Well, to do this, we have to understand that that angle can be described in terms of a tangent function, where we have the tangent of that angle is equal to 21 over 25. And to get that, I kind of have to cheat a little bit. We're not quite there with this stuff, so it's looking a little bit ahead, but we are going to get to the point where we have to talk about a thing called an inverse trigonometric function, where what an inverse trig function is a function that you use to undo a trig function. That is, if you have side lengths and you want an angle, like we do here, you can use an inverse trig function to get there. And that's something we're going to see a bit later on in the chapter, but it's good to get a little preview ahead now for why we might care about it and how we can use it. Because in this case, if we apply that inverse function, which you're going to see a little bit of calculator work in order to be able to get, you would have that A is equal to approximately 40 degrees, where you really would need a calculator to get that, but anyway. We'll see more about that stuff next week.